Hi guys, we are back with round 2 of Impulse, just adjusting our viewing area again. So we have an equation for impulse. We know that impulse has to do with force and time and a change in momentum. So just a couple other things. Impulse, I need you to understand it can be both positive and negative, which means it is a vector quantity. Okay? Impulse can be both positive and negative. What does that mean? Vector, vector, vector. Okay, remember, vectors are those things that have magnitude and direction. All right, the greater the impulse, the greater the change in momentum. They go hand in hand. The greater the impulse, the greater the change in momentum. Okay? So the greater the impulse, the greater the change in momentum. Based on that equation, Ft equals m delta v. This right here, this is impulse. So if you make the impulse bigger, right? If you make that product of Ft bigger, that means the delta V times the M will get bigger. They go hand in hand. You raise this side, you raise that side. Okay. So let's see. Let's take a quick look at an example. Case A and case B. Both have a ball that is traveling at 10 meters per second towards a wall. This ball hits the wall at 10 meters per second. It then bounces back at 5 meters per second. On the other hand, this ball goes in at 10 meters per second, bounces back at 10 meters per second. Which one has the greater impulse? This is a ball, by the way. Which one has the greater impulse? Remember, impulse is a change in momentum. So this one, and momentum is a change in velocity. So this one went from 10 meters per second to 5 meters per second. So it went from 10 down to 0, back up to 5. An overall change of 15. This one went from 10 down to 0, back to 10. An overall change of 20. You got it. So this one right here has the greater impulse because it's changed from positive 10 to a negative 10, right? Okay. Excellent job. Excellent job. Let's pause this video for 1 second. All right, so now I'm going to go over the first problem in a problem set that I will be sending you. I'm going to email this out as an attachment. So this is going to be exercise number 2. It's the first problem. Auto companies frequently test the safety of automobiles by putting them through crash tests to observe the integrity of the passenger compartment. If a 1,000 kilogram car is sent towards a cement wall at 14 meters per second, and the impact brings it to a stop in 8 times 10 to the negative 2 seconds, with what average force does it have, or is it brought to rest? So let's get all this information up on the board, and I'll join you in just 1 second. All right, so we have a mass of 1,000 kilograms. They told us it was originally traveling at 14 meters per second. However, it brings it to a stop, and we're looking at a change of velocity. So we go from 14 at an initial velocity to 0 at a final velocity. Then we have our time of 8 times 10 to the negative 2, or 0.02 seconds. And we want to try and find that force. Remember your equation, fill it in. Be right back. Filling this in, Ft equals m delta v. Remember, delta v is a change in, so final minus initial. We have our force times 0.02 equals 1,000 times 0 minus 14. F times 0.02 equals 1,000 times negative 14. Going through and solving this, we'll join back in just a second. All right, my apologies. I made a little mistake. It should have been 0.08 instead of 0.02. But as we go through and solve this out, we multiply our negative 14. We divide over, and we get a final answer of negative 175,000 newtons. So don't forget to subscribe, to hit the like button. Hope you enjoyed this. I'll follow up. I'll see you guys all later. Stay safe. Fabs out.